Hi, everybody. I'm recording this video as a very short correction or clarification video for Lecture 14. Lecture 14 introduces us to the concept of an op-amp. And there were a couple of places in the video where I just kind of went off the rails, to be honest, and started just saying weird things about inconsequential things, and it became very confusing. So in about a minute, I just wish to make some clarifications. The first thing is I want you to see that I have put those clarifications in the comments of the video itself, okay? So in the video itself, below it, I wrote 3 comments. The first, I started talking about negative feedback loops. Now, the negative feedback loop is necessary for the condition of linearity. So in other words, if there's a possibility of your op-amp operating in that ideal or linear range, you have to have a negative feedback loop. What that means is there must be a resistor that goes from the negative input terminal to the output terminal of the op-amp. If that does not exist, then you can't assume linearity. So I started to talk about feedback on the positive terminal, or from the positive input terminal to the output terminal. And there's just no reason to even talk about that at this point. So for an op-amp to be operating within the linear region, in other words, to have ideal behavior, you have to have a negative feedback loop, which means that you have a resistor across from the negative input terminal to the output terminal. That's it. Easy if I say it in a simple way. So and I sort of tied this in with the idea of a non-inverting amp and an inverting amp. But in either case, whether the amp is inverting, non-inverting, summing a difference, or some other sort of an op-amp, you always have that for a negative feedback loop. But for a non-inverting amp, the V-in is on the positive terminal, whereas on an inverting op-amp, it's on the negative terminal. So remember, an inverting op-amp produces the same numbers, but it flips the wave, or it's a negative. The voltage out is a negative of the voltage in, or it's 180 degrees off. For non-inverting, V-in is on the positive terminal, and it does not change the sign or the phase of the wave. So that's the first point. The next point I wanted to make is that VCC, which they talk about a little bit here, is it's the why do they use the subscript CC? Well, it refers to common collector. So what they're saying is both go to ground. So it's the common, or on both the positive and the negative, you're going to ground or to the same level of potential difference. So I guess those two things are relatively easy to understand. But I wanted to make them clear because the way I said them certainly did not make them seem like they were easy in any way. All right, so that's a short correction video. Let me know if you have any questions. Thanks.